Recording in progress.
সবাইকে আসসালামু আলাইকুম। আমি তাসনিম মাহি, আইটি স্টুডেন্ট চ্যাপ্টার বুয়েটের এক্সিকিউটিভ মেম্বার। সবাইকে আমন্ত্রণ জানাচ্ছি আমাদের আইটি বুয়েট স্টুডেন্ট চ্যাপ্টারে আয়োজিত আজকের ওয়েবিনারে। আমাদের আজকের টপিক সিভিল ইঞ্জিনিয়ার্স জার্নি টু স্ট্যাটিক্যাল অ্যান্ড ইকোনোমেট্রিক মডেলিং। আইটি একটা আন্তর্জাতিক সংগঠন যা ট্রান্সপোর্টেশন ইঞ্জিনিয়ারিং নিয়ে কাজ করে। এর একটি শাখা আইটি স্টুডেন্ট চ্যাপ্টার বিশ্ববিদ্যালয় শিক্ষার্থীদের ট্রান্সপোর্টেশন ইঞ্জিনিয়ারিং সম্পর্কে সচেতন এবং দক্ষ করে তোলার জন্য কাজ করে। আমাদের আজকের এই বিশেষ আয়োজনে আমরা প্রথমে আমন্ত্রণ জানাচ্ছি আমাদের সাথে যুক্ত হওয়া সবাইকে। আজকে আমাদের ওয়েবিনারে মূল বক্তব্য রাখবেন ডক্টর অন্বেষা এনাম, বাংলাদেশ প্রকৌশল বিশ্ববিদ্যালয়, ডিপার্টমেন্ট অফ সিভিল ইঞ্জিনিয়ারিং এর অ্যাসোসিয়েট প্রফেসর। ম্যাম ইউনিভার্সিটি অফ কানেক্টিকাট থেকে পিএইচডি করেছেন। এরপর এমআইটি অ্যান্ড অর্গান ন্যাশনাল ল্যাবরেটরি রিসার্চ অ্যাসিস্ট্যান্ট হিসেবে কর্মরত ছিলেন। আমরা ম্যামকে আজকের ওয়েবিনারে স্বাগত জানাচ্ছি এবং ম্যামকে অনুরোধ করছি ওয়েবিনার শুরু করার জন্য।
থ্যাংক ইউ তাসনিম ইন্ট্রোডাকশনের জন্য। আমি একটু জানতে চাচ্ছি টকটা কি সাধারণত বাংলাতে হয় নাকি ইংরেজিতে? আমি যেহেতু আগে পার্টিসিপেট করিনি, আহ কিভাবে মানে ইংরেজিতে বোধহয় সেরকম দরকার নাই, কারণ মোস্টলি আমাদের স্টুডেন্টরাই। তারপর তোমরা কি কিছু ফলো করো নাকি, বা তোমাদের কোনো রেকমেন্ডেশন আছে নাকি?
না, নো ম্যাম, আমাদের রেকমেন্ডেশন নেই। আপনি যদি চান ম্যাম ইংলিশও নিতে পারেন।
আচ্ছা, আমি তাহলে বাংলাতেই বলি। তো
আহ,
বাংলা ইংরেজি মিশে বলবো আর কি। স্ক্রিন শেয়ার করি, আমাকে শোনা যাচ্ছে তো না?
জি জি ম্যাম, শোনা যাচ্ছে।
ঠিক আছে। আম, আচ্ছা, আমি তাহলে ইংরেজিতেই বলি, বরং ইংরেজিতেই শুরু করি। টেকনিক্যাল টক তো হয়তো ইংরেজিতে বেশি সুবিধা হবে, মাঝখানে হয়তো বাংলা আসবে, ওরকম হতে পারে। বাট কেউ যদি ওরকম কোনো স্পেসিফিক রিকোয়েস্ট থাকে যে কোনো একটা ল্যাঙ্গুয়েজে মোর প্রেফার করছে, তাহলে সেটা আমাকে চ্যাট বক্সে জানালে আমি সেটা চেঞ্জ করার চেষ্টা করবো আর কি। আহ আচ্ছা। Um, so welcome everyone. I think most of you are undergrad students at BUET. So this talk is a little different from the kind of talks that I usually give at different conferences. Um, because I wanted to talk about this because most of you are at a stage of your life where um, you are only thinking about civil engineering. But when I look at myself, I feel like what I'm doing right now, it doesn't have much to do what what I was taught during my undergraduate years. That's because I'm a transportation major, and most of you by this time know that at BUET at least, the civil engineering mostly focuses on structural engineering and geotechnical engineering. Then when I had to switch to transportation engineering, my undergrad major was structural engineering and minor was transportation. But when I joined as a lecturer at BUET, I was asked to join as a lecturer in the transportation division. So that's how the switch happened. And afterwards, when I started at my MSc, I completed my MSc at BUET. During my MSc, during my PhD, and afterwards, whenever I worked, the topics that I dealt with had very little to do with what I was taught during my undergraduate studies. So I mostly deal with the statistical and econometric modeling till now. I don't know whether I'm gonna shift to some other field in the near future, but till now I mostly deal with statistical and econometric modeling. So that's what I wanted to focus about. I just wanted to share with you that I'm sure most of you are having a wonderful journey. I also had a wonderful journey as a civil engineering student. But if you want to venture into other fields, it's very much possible. And I want to share with you what transportation engineering is to me, because as a civil engineering student, most of us don't get that opportunity to know much about the transportation engineering. At least for my case, I got to know about transportation engineering after I started my master's. I was lucky enough to get somebody as my supervisor, who at that time recently finished her PhD. And she actually introduced me to this world of transportation engineering. So transportation engineering can be defined from different people's perspective, but today I'm going to talk about my perspective, how I got introduced to this field, and what I'm doing right now in this field. So that's the idea of the talk. It's going to be a little bit technical, but I'm not planning to get into the technical details of anything. I am just willing to share my journey and how I started and where I'm right now, so that some of you might get some idea about where you want to move on in the near future. So yeah, I started as a civil engineering student at BUET. I was very happy as a civil engineering student. I didn't want to get into EEE or CSE. I got civil engineering and I was happy with that. It's not that I wanted to shift to something else. Then when I started my MSc, I actually started to call myself a risky choice modeler. And that's where I wanted to study actually during my PhD. But fortunately or unfortunately, during my PhD years, I started to call myself a multiple display choice modeler. And then when I started my postdoc, I started to call myself an agent-based modeler or microsimulation modeler. And currently, I try to apply all the knowledges that I've gained in the last, I would say, 15 years or so in the field of transportation engineering. I use data from Dhaka, and I want to apply that knowledge along with my students. So I would like to focus on that. I'll be focusing two studies that I've conducted with my students, and I'm very proud about those studies as well. So yeah, how did I get introduced to transportation engineering? The way I got introduced to transportation engineering, or the way I understand transportation engineering, to me, it is basically understanding and analyzing the choice of people. So the choice could be your residential location. The choice could be where you want to work at, your workplace location. The choice could be what activities you want to participate in during a day. The choice could be for what duration you want to participate in during a day. The choice could be the time at which you want to start a certain activity. For example, the time at which you want to get up from your sleep at the morning. Your choice could be whether you want to travel during a day or not. Your choice could be which transportation mode you want to use during a day. Your choice could be the route you want to take during that day. So that's what is transportation engineering to me, to some extent. So if I pictorially show you, it's kind of as a transportation engineering, this is why I understand as a transport modeler, I basically want to capture people's daily activity schedule. So how they're moving within this cycle. They start from home, they go to somewhere using something at a certain time period. From the workplace, they go to somewhere else, they come back, then they move to the gas station, they come back to the grocery store. From there, they maybe pick up their kids from the daycare center, they come back to home. So in this cycle, at what time they want to do these activities, which mode they want to use, whether they want to do these activities virtually or in person, those are the choices that I play with, or I try to understand and try to model. But when I started as a master student, I didn't understand that all these choices actually fall within the category of a transportation engineer, within the realm of a transportation engineer. What I understood is that the job of the transportation engineer is basically to model whether the person wants to travel or not, and the transportation mode that they want to use for their travel. So that's why what basically I focused on during my master's is what transportation mode people want to use when they travel. And this is actually a very important decision, because you would notice that if we group the transportation modes into two very broad categories, we basically have private car and we have public transportation that is not owned by us. So if there is anything in the chat that I need to look at, since I'm sharing my slide, you can, whoever was hosting the Tasnim can tell me if I have to look at something, because there's something in the chat box. Okay, so the choice of mode is actually a very important determinant of the number of vehicles that's going to be on the road. That's because if we push people towards public transport, consequently, the number of vehicles on the road will reduce, because of public transportation, because of its sheer size, it can carry more people than a private car. So this is a very important decision, and that's what I focused in when I started my MSc studies. So, but for this modeling, we need data. And so when we talk about data in transportation, we talk about two, again, very broad categories of data. We call these revealed preference data. Revealed meaning the choices that are revealed, that we can see actually. People are making these choices in front of our eyes, and we can see it and we can record it. So these are revealed. And another type of data, which is the stated preference data, which we don't see actually people to make those choices. For example, today I don't know if the BRT starts to run on Dhaka Street, whether people are going to use it or not. But I can ask people that today using a bus, it might take 40 minutes for you to move from A to B. But when the BRT comes, it will take you 30 minutes. But to save those 10 minutes, you'll have to pay 20 taka more. And we can ask them to give us a preference, whether they are going to continue to use the current bus or they are going to shift to BRT. So that's the stated preference kind of data, where I am not actually observing the choice, or the person is actually not making the choice. They are stating that if that situation arises, the person will make that choice. So I actually kind of understood what these two types of data are. I understood what survey design is in transportation domain, how to design a stated preference survey, how to design a revealed preference survey, and how to model by combining these revealed and stated preference data. So on the right-hand side, what I have is basically a questionnaire of a rebuild preference survey, we can ask people these type of questions that we can try to capture the basic details about the person, and then we try to capture where the person is traveling, at what time, using which mode, for what activity. This kind of information we basically capture during a rebuild preference survey. Okay, then this is the data collection part. So I learned about survey design. I learned about these two types of data. Then I had to do something with the data. So I had to analyze the data. So then my supervisor is currently a professor at University of Leeds at UK. She is not anymore with us at BUET. But then she introduced me to this modeling realm, which we refer to as random utility models. So how do we model? Then people have these choices. They have private car, they have CNG, they have tempo, they can walk, they can take motorcycle, they can take bicycle. So how do people decide which mode they want to take? So then I was taught, or I read about it, and I realized that um, this is one way of thinking about it, is that people actually associate a certain utility with these different modes or different alternatives. So they, in their head, they are basically associating an utility. What amount of utility am I getting by using bus? What amount of utility am I getting by using public transport? What amount of utility am I getting by using CNG? So basically, we are making a trade-off between travel time and travel cost, if not anything else, right? And then we are calculating these random utilities, and the mode that is giving me the maximum utility, I'm actually taking that mode. The same thing applies for the route choice as well. So from here to BUET, I live in Dhanmondi. So from Dhanmondi to BUET, I can either go using the route in front of the New Market, or I can take the Kazi Nazrul Islam Avenue, or I can take the Elephant Road route. So these are the choices I have. So basically, obviously, I'll think about my time, and then I'll think about my cost, if not anything else. I'll think about my comfort, and then I'll make a choice that I'll choose the route or the mode that gives me the maximum utility. So that's the model I was introduced to, and that's what I learned, that you basically associate an utility to all these different modes or all these different routes, and then you choose the mode that have the maximum utility. But how do you calculate this utility? So you are probably making these calculations in your head. I don't know what's inside your head. So as a modeler, how do I capture utility? So basically, utility is nothing but an equation, which is a function of different variables and different parameters. So it's just, utility is nothing but a simple regression equation, where on the right-hand side, I have different variables like the time that it takes to go from A to B, the cost, my gender, my income, and I have certain parameters along with this variable. So that's all I have. And then a model means basically you have to identify the values of B1, B2, B3. Okay. So that's what I was introduced to during my undergrad studies. And then also I realized that, so since people are associating a certain utility, so as a modeler, what I can give you is, for example, if you are the chief advisor, currently you are sitting on my head, you are my chief advisor, the chief advisor of the country, and you want to know what percentage of people will be taking car versus what percentage of people will be taking BRT. If I introduce a BRT, what percentage of people will be taking the local bus? So as a modeler, I'll be able to give you the probability. So if you can calculate the utilities, the advantages, you can come up with the probability, the share of the people who will be taking different alternatives. So that's how much I was taught during my undergrad studies, and that's what I applied. So for estimating these random utility models, I realized that you cannot do it using your papers and pens. You cannot solve these models in your hand. You can solve probably one model, but when you try to estimate the parameters of these models, you have to estimate, say, 100 models. So it's not feasible to do that manually and then to pass your master's, right? So to submit your thesis on time. So you need to take support from some kind of a software. So these were the softwares that I got introduced to back then as well. Biogene, Gauss. I started with Biogene, and then I ended up using Gauss for my master. So these are just some screenshots. I'm a civil engineering student. I was a okay student in programming. I had keen interest in programming, but I was not a programmer per se, but I could pick it up. So you can pick it up if you want to as well. So when we estimate these models in any of these softwares, basically you get the values of these parameters that you estimate. That's all basically. Nothing else. So beta 1, beta 2. So these are the what you are seeing as ASC car, ASC bus. These are nothing but the parameters that you are estimating. If you think about a regression equation, I know many of you might be familiar to regression equation. So you are basically estimating the parameters of a regression equation. That's how you can think about it. But then when I started my PhD, I was forced to realize that travel is a derived demand. What does that mean? So that means that I was very fascinated by what mode people want to take, which route people want to take. But suddenly people made me realize that it's not like people get up in the morning and then they decide that I want to travel today and then I want to take my private car and I want to take that route. It's not like that. It doesn't happen in that way. Basically, people decide about which activities they want to participate in. And then they decide about at which locations. For example, if somebody wants to buy a dress for, say, a program, um, they think about which shop they want to go to and what time. If they have BUET, they will go in the evening. If they don't have BUET, maybe they will go in the morning. It also depends on when the shop is open. It also depends on whether it's a weekday and weekend. So basically, people think in terms of the activities they want to participate in. And people don't usually travel for the sake of traveling. So that's something that I was made to realize during my PhD years, that we need to start thinking about the activities. The trips are the kind of the consequence of engaging in the activities. We want to participate in activities, we want to change our locations. It's not possible to participate in different activities by sitting in my home. I mean, today you have made a very nice opportunity for me to talk while sitting at home. This is a virtual participation, but in most cases, we change locations between consecutive activities. That's how we participate in multiple activities. So, and since we have to change location, so that's why we have to participate in trip. So trip is actually a byproduct of my need to participate in an activity. That's what I realized when I started my PhD. And people rarely, though there are some portion, some kind of travel where people just travel for the sake of traveling. So, for example, somebody is dating someone and they want to go into a travel just for the sake of traveling. So that's a different scenario, but that happens. That doesn't happen very often. Most often, we travel because we want to participate in activities and we want to change location. So then I was told that now the state of the art is you have to try to understand what people want to do during the day. You have to try to understand people's activity schedule. And then I was made to realize that it's not just enough to start thinking about which mode they are going to take for different trips and which route they are going to take for different trips. You have to start at the route. The route is basically people start thinking about which activities I'll be participating in during the 24-hour period. So this is just a screenshot of, this is not very, I know this is not explaining anything to you guys, but this is just a screenshot of one of the works that I've done. So what I was trying to do here is basically, I was trying to divide the 24-hour period of a person's day into these 9 types of activities. So the person, and also it's not like it's not a discrete choice anymore. Discrete choice meaning for a mode, for a trip, you can decide like I would be taking a BRT or I'll be taking a bus or I'll be walking. But when I talk about what you are gonna do during 24-hour period, it's not a discrete choice. It's not like I'll either sleep all day or I will just study all day. It's not like that. It's obviously it has to be, you'll have to eat for a certain period of time. You'll have to spend some social time. You'll have to take bath for a certain time. You have to study for a certain period. You have to go to your school for a certain period of the time. So you have to divide your day into multiple activities. So that's what I was made to realize, that the discrete choice modeling that which I was taught during my master's is not enough to model these kind of choices, where people are actually dividing a continuous dimension into multiple activities. So this is the model where I was trying to do that, to divide. So here you would notice that what I was trying to do is basically I was trying to identify which activities people are participating in and for what duration they are participating in those activities. And if somebody is participating in an escort tour meaning somebody is going out of home, doing something where they are dropping off somebody and then coming back home. They can do other things as well in that tour. Maybe they have stopped for a meal. Maybe they have stopped for shopping on that tour. So basically, I was trying to understand how many tours people are making and how many stops are there within each of the tours and what are the durations of those stops. So basically, I moved a little up from the mode choice and route choice to the activity choice and the time allocation. So for that, I realized that when I'm dealing with these kind of choices, the random utility model is good. But what I did during my PhD is that I realized that it's not enough to just try to explain these choices in terms of the variables that we usually deal with, like my age or my income is not probably enough. I have to then include people's attitudes. Um, because somebody can be very laid back type of a person, somebody can be a multitasker. So to model these kind of choices, people's activity, participation, time allocation, these are very innate to one's personality. So that's why I have to capture these things, which are very difficult to capture because, when I ask about your age, I know that you'll respond to me in the unit of years. So if I ask about your income, you'll respond to me in the unit of, say, taka or dollar or one of the units of money. But when I ask you about your personality, if I ask about five people will explain differently to me how they see themselves. So there is no scale to measure these kinds of attitudes. So that's why it's very difficult to include these types of variables, which we often term latent variables, into the models. So I had a little bit of contribution in here where I tried to capture these latent variables into the models of activity, participation, and time allocation. So if anybody is interested in this group of research, other professors at our department who have recently joined have also worked in these fields and have been working in these fields. You can look into their papers and my papers also. Okay, so next, so I have learned all these types of modeling or try to do this kind of modelings, and I was very excited about it. But um, what does that have to do with transportation planning? So as a transportation engineer, what we want to do is basically we want to make informed transportation decisions. So that's what the decision makers want to do, is that they want to make some informed decisions. So from 5 years from now, what does Dhaka need as a city to thrive in transportation division? So what does Chittagong needs to thrive in the transportation sectors in the next 5 years, or in the next 2 years, or in the next 10 years? So we as transportation modeler, our job is to help the transportation, not the transportation professionals, but basically the authorities of our country who are the decision makers, to help them to make informed decisions. That's what we do as transport modeler. So then I started to think about how to actually use these models to help make informed transportation planning decisions. So then came the agent-based modeling or microsimulation modeling. Microsimulation modeling is basically where you are actually simulating the activity and transportation behavior of a city or of a metropolitan area or of a region or of a country. Um, but when you're simulating the behavior of different people of a city or of a region, you have to embed the behavior of those people. So the behaviors are coming from these models, these behavioral models that I have tried to talk about so far. So you have to estimate those models and your agents. For some of you might be playing video games, right? Some of you might be very familiar and very fond of video games. So in the video games, how different agents are behaving, they are actually programmed to behave in a certain way depending on how their characteristics have been programmed. So that's what we modelers do. We basically model the behavior of the different agents of a city, and then we have to simulate those agents based on the embedded behaviors. Okay, so if that makes any sense. So during my PhD and during my postdoc actually at Argonne National Lab, I started there as a postdoc, and then I moved on to research scientist position. But yeah, then I realized I started to work with a tool called Polaris, which is a micro simulation tool. It was an open source C++ code, but now it's not open source anymore. They are trying to commercialize it. So basically, here the blue box that you were saying. During my PhD, during my master's, my contribution was basically to come up with these models, the travel demand models, the travel behavior models. But then when you feed these models into the micro simulation tool, where every person will be making a decision based on the models that you have embedded, then we can simulate the traffic flow based on the decisions that people are making. So when you can simulate the traffic flow, uh, but again, where is the excitement? You can simulate the traffic flow. I can see the traffic flow if I go outside in my city, right? I don't have to simulate the traffic flow in order to understand how the traffic flow is happening. What I can do is I can just capture the baseline data. However, my traffic is flowing in Dhaka, I can just capture this data. If I have enough time, enough number of surveyors, I can just do speed survey, I can just do volume survey, and I can determine how my traffic is moving on my roads. But the beauty of microsimulation model is that it will not only give you the idea about the current scenario, you can also get some idea about the future scenario. So what is a future scenario? A future scenario is if you want to introduce a metro rail line 5 as opposed to a metro rail line 1, which one will be more beneficial to you in the near future? So that's the kind of question that you can ask a microsimulation model, because it's very difficult to actually implement Metro Line 1 and then decide, oh no, Metro Line 1 was a bad decision. I should have implemented Metro Line 5 first. But in a microsimulation model, since it is a virtual world, you can actually do that. Once you have a baseline model where you can replicate the baseline scenario relatively well, if you can replicate the current scenario of Dhaka relatively well, what you can do is basically you can introduce a Metro Rail Line 1, and then you can see how your city is behaving, as opposed to if you introduce Metro Rail Line 5, how your city is behaving and which one will be more beneficial in the near future. So that's basically the job of microsimulation model. So I started to get a taste of that during my work at Argonne. So I'll give you a few more. I'll try to give you a few more examples. This might not look very interesting, but the work were quite interesting, I would say. So this study was done for Chicago metropolitan area. So basically, we were trying to see from the baseline. So these were the baseline scenarios. So obviously, this has to match with the current scenario. So in the current scenario, these are the million trips in a single day. 42 million trips were being generated at the current scenario. This was the scenario for 2018. In the 2018, in Chicago metropolitan area, 42 million trips were being generated. Okay. So now from there, we wanted to see if we increase, so we actually tested 3 different scenarios. So we call these scenarios, one is, I'm going to explain these scenarios in a little bit, but first just let me tell you what are the name of the scenarios where. The scenarios were high sharing, low automation, high sharing, high automation, and low sharing, high automation. So sharing means if you can move people from private car ownership to a world where people will be owning less number of cars, but they will be basically be riding on shared vehicles, the vehicles that will be shared among multiple people. So kind of like Uber type of vehicle or Pathao type of vehicle they'll be using mostly. This is the scenario they were interested in because unlike Dhaka, where the car ownership is only like 6-7%, in the Chicago, the car ownership in the baseline was almost 98% in the Chicago metropolitan area. So that's why they wanted to test a scenario where the car ownership will go down, but people will start to share the private vehicle more, because it's very difficult to move people to the public transportation where people are so used to using private cars. So what you can do is in those scenarios, you can at least try to reduce the car ownership. In that case, people will at least reduce their unnecessary trips when they start sharing vehicles, because they will not be owning vehicle. The vehicle will not be with them when they don't need to take a trip. So that was the idea. And automation means, you know what automation is. So it comes from the automated vehicle. So when the automation level is low, meaning the penetration of automation vehicle will be low, and high means when the penetration of automation vehicle will be high. So basically long story short, basically what we found is this is the best scenario in terms of the um, terms of the transportation planning and energy emission and all those kind of things. And this was actually the worst scenario, because at this scenario, when the sharing is low, meaning you will allow people to own automated vehicle, um, and the level of automation will be very high. That means the automated vehicles will be running in level 5 automation. At those scenario, people will be traveling the most, and the what we call is auto empty miles. So auto empty miles, how do we define it? Auto empty miles is, interestingly, this idea is actually relevant to our city as well. They call empty mile when the car is running without somebody in the car. That is possible when the vehicle is automated, right? There is no driver, but the car is running. So the vehicle is basically moving from one place to another. So empty mile does not serve anyone, because in transportation, we actually forget that um, our objective is to move people from one place to another. Our objective is not to move vehicle from one place to another. We forget this basic thing very often, that our objective is basically to move people and not vehicles. So empty miles is where the vehicle is moving, but no person is moving. So that's why your objective should always be to reduce empty mile. Now, what is the a parallel uh, scenario for Dhaka? A parallel scenario for Dhaka is where the car is moving, where the car has only the chauffeur in the vehicle, meaning only the driver. So the driver is just moving the vehicle from one place to another, and that happens on many occasions in Dhaka, because in Dhaka, in a multi-member family, actually one single car serves the purpose of many members of the family. So the empty miles actually occurs in Dhaka as well, but we never captured that in the way Chicago has. So we saw that the empty miles will actually drastically increase in case of the low sharing and high automation scenario. Okay. Uh, and and then the total number of trips making will also increase. So the network will become very congested if we go to the low sharing and high automation scenario. So this is the similar kind of, I'm just trying to depict the same thing using a graph. I'll share the papers with you if anyone is interested, but I'll move on right now because I think I'm taking too much time. I want to talk a little bit about the works that I'm currently doing at BUET as well. So this is another scenario where we actually wanted to test what will happen if the online shopping becomes very popular. So we noticed that if we actually completely shut down. This is also applicable to the Chicago area, Chicago metropolitan area. We tested this scenario for Chicago metropolitan area. So we noticed that if we shut down the retail shop completely, meaning the people will not be going to the shops to get their groceries or get their, the regular shopping, what will happen is basically the VMT will reduce. VMT is the vehicle miles traveled. Vehicles miles traveled will reduce because the orange lines is basically when the people is moving. This is the LDV, meaning the light duty vehicles, the private cars are moving. So the private cars will not be moving in the scenario where people will not be going to the shops, rather the goods will be coming to them only. But obviously the medium duty truck delivery will increase. So the VMT of the medium duty trucks will increase. But what interesting is the microsimulation models have the ability to show you different aspects of the same scenario. So we noticed it that in terms of VMT will go down drastically if we rely on online shopping only. But in terms of energy consumption, that actually doesn't go down drastically because the MDT, the medium duty vehicles, actually consume much more energy than the light duty vehicles. So the energy consumption, if we depict the same picture in terms of the energy consumption of the transport sector will actually be almost similar to the case where some of the retail shopping is there and some of the online shopping is also there. Okay. Again, this is from another paper. We can share the paper with you if you're interested. So now I want to talk about a little bit. I think I will skip this one. I'll talk about the next study first, because I'm more interested in that study. So just to give you an idea. So I started to basically work at BUET from the January of 2021. So I have done, so students have done undergrad thesis with me. The 16 batch has done undergrad thesis with me, and then the 18 batch has done, and the now 19 batch is doing currently. I missed the 17 batch because I was in maternity leave then. So I have two studies basically. Both are have been presented and published. So this study is the online shopping behavior of Dhaka. This study was conducted with my students from the 16 batch, Imtiaz and Sadia Afrin. They have conducted this study and this has been published. So I'm very excited about this study, but I'll leave it for now because I think I'll not get enough time to talk about it. If I have time, I'll talk about it afterwards. I'll move on to the second study, which I'm more interested about. And this study was conducted with my students from 18 batch, Kaisar and Atul. The Kaisar has already moved on to Texas Tech, and Atul is planning to move on. He's also applying right now. So here, so on my first or second slide, probably I introduced the concept of data collection, right? And many of you who are conducting currently studies or will be conducting studies very soon, you know that to conduct any transportation studies, we basically need lots of data. So the idea is to design a survey and then to collect the data. And then I told you that during my master's, I also learned that how to do it, how to design a review preference survey, how to do a status preference survey. But the thing is, these methods of data collection are called the active data collection methods, where you are making the participant or the respondent actively participate in the data collection process. And this is sometimes very time consuming, very costly, and it's very difficult to motivate people to give their data. So that's why in transportation domain, it's very difficult to get quality data and to get the enough data for doing any meaningful modeling. Okay. So that's why in transportation field, we are always in look for passively collected data. So what is passively collected data? Passively collected data is where you are not bugging the respondent or the participant for the data, but the data is generated for some other reason. You are just using that data for your purpose. So how is the data generated passively? For example, when you are doing a check-in in the Facebook or the Square app or the Instagram, data is being generated. When you are using a smart card for alighting into a public transit, you are actually generating some passive data. When you're using a location application, for example, Google location, Google Map, you are actually generating data. So these are called passively generated data because nobody, this data is not being generated for the purpose of any travel behavior analysis or any modeling per se. This data is just passively collected, but you can use it. Whether you can use it or not for your purpose is the question. So for this study, our question was whether we can use Google location history data for travel behavior research in the context of Dhaka. So I didn't check for all the country. The study was particularly for Dhaka. So if you don't know what is Google location history data, if you use a Google map, if your location is on your smartphone, Google is basically collecting the locations at which you are moving. So this is my location history. So if I keep my location location information on, if Google can access my location information, they basically can give me, this is called timeline in Google Map. So they can give me in a certain month or in a certain year at which locations I have went to. Okay. But we needed actually more specific data than that. So basically Google keep more specific data than that as well. So they don't only give you the locations where you have visited, they also can give you the your route. They actually give you the geographic coordinate of the routes that you have taken, the modes that you have taken, all this kind of information they actually store. And if you want, they will share this data with you. So you can only take your data. I can't take your data. So you can download your Google location history data from your Google service, but I cannot do it. So what we did is, what we wanted to do is, we wanted to see if we can collect this data from different people, if they can give us this data, how accurate this data is, whether we can use this data for travel behavior analysis. So basically, what information does Google have? They give us the location data, including the geo coordinates, meaning the latitude, longitude. They give us the timestamp corresponding to the geo coordinates. So they will tell me at 5 p.m. 8 minute, you were at this latitude and this longitude. At 5 p.m. and 9 minute, you were at this latitude and this longitude. They will also try to infer the location at which you have participated in different activities. They will also try to infer the transportation mode that you have taken to move from one activity location to another. So it looks like a lot of data. So basically, we wanted to see whether this is reliable. So this was basically our primary idea. This was our primary scope of work, that we wanted to see whether Google can identify, whether from the Google data we can identify from the GLH. I'll refer to the Google location history data as the GLH data from now on. So whether we can identify somebody's home and work location, whether we can identify the trip arrival time, departure time, the location from where the trip is starting and the location at which the trip is ending, and whether we can identify the transportation mode of the person. Okay. But then when we started this work, we realized that Google is making some very systematic mistakes. For example, they can never actually give me the correct prediction for the non-motorized modes. They can never tell me when a person is using rickshaw, they will identify it as, say, walking or in car or somebody else, something else. They will never give me it as rickshaw. Similarly, they could never predict CNG. They could never predict tempo. So these were very systematic errors. So these were not like they were 1% error or 2% error. Always they were actually misinterpreting these modes. They were not correctly interpreting these modes. So that's when we started to think about whether using the information from Google, for example, the information that Google is giving me, that at which speed a person is moving. Because if you can get the location stamp and the time stamp, you can calculate the velocity and the acceleration of that person. So whether using that velocity and acceleration information, whether you can develop a model that can predict the transportation mode better than what Google does. So that was actually our added objective. Initially, we didn't start with this objective, but based on Google's performance, we thought that this will be a good addition to the work that we wanted to do. So for this actually, so we wanted to check whether Google is giving me reliable data. So for that, we had to collect another line of data. We had to collect the ground truth information. Ground truth meaning the actual information. So if Google is telling me this person has taken car to go from BUET to Nilkhet, I have to validate that against something. So to validate that, we actually had to collect the actual information. Then again, we thought that if we want to collect the actual information, we have to ask that person which mode actually that person has taken, and it will be, again, the person can give me wrong information about their time and mode and all these kinds of things. So basically, Kaiser came up with an in-house application. He actually ended up developing an app. If the person keeps running this app in their smartphone, the app will be collecting the data, and this will be the data, meaning the person will have to input only the mode information, the trip start time, the end time, and the start latitude, longitude, and the end latitude, longitude will be collected by the application. But the person has to manually input the transportation mode, because we were more concerned about checking the Google predicted transportation mode against the ground truth mode. So that's why the mode information was given manually by the person. Okay, so this was the application developed by us. So I'm just keeping it short. We did a lot of things in between. I'll not share that, but then we developed the mode choice, mode prediction model. We basically used LSTM, long short-term memory model, in a neural network, and then we also use a random forest. So when you can, if you are familiar with a confusion matrix, you will notice that, for example, this is the GLH prediction. So when actually a person is using MRT or metro, the Google GLH was actually predicting it as metro in case of in less than 20% of the cases. For most of the cases, for 55% of the cases, it was identified as a passenger vehicle. So when we applied the LSTM model, the prediction did improve a bit. And then when we applied a random forest model, it improved a little bit more. Again, we couldn't reach the 100% prediction because again, we were relying only the travel time, the velocity, this kind of information we had from that person. We didn't have any socio-demographic information. So we couldn't predict 100% accurately, but at least our prediction was better than what Google was predicting. So these were the key findings. The key findings were from the Google data, we were actually able to satisfactorily identify the home location and the work location of the respondents. We could satisfactorily identify the trip information, such as at which time a trip is starting, at which time the trip is ending, from which location the trip is starting, at which location the trip is ending. But the GLH predicted modes were not satisfactory. So the GLH accuracy for mode prediction was only 53% because it was always missing the rickshaw, the CNG, the tempo. And with our model, the LSTM prediction was not very good. It was 68%, but it was better than Google. And then with random forest, we did a better job, and it was 86%. Okay. So now I think I'll stop here because I have kind of probably we have 15 minutes because the program was advertised as a 1 hour session. So I'll stop now. And if you have any question, I'll be very happy to give you the answer.
Madam, I had a question.
Yes, go ahead.
আচ্ছা যাদের কোয়েশ্চেন আছে
It's a technical one. It was about the activity-based modeling. If I'm right, activity means that it's a series of events, right? So I was thinking that how did it model uncertainty? For example, a series of events could be I go to school, then I go to shop, then I go home. But what if after I go to school, it rains and I decide not to go shopping? Then what happens?
Yeah, very
I
good
mean, how do I
question.
model that?
Yeah, a very good question. I can respond to this, and I can take another 1 hour to respond to your question. Actually, all of these models are probabilistic. Okay, so I'll highlight two things. So a series of events, yes, you can model the activities in many different ways. So you can model it as many different events, and then at many different events where different events are starting, the start time, the end time. There are different ways of modeling these activities. So modeling it as a series of events can definitely be one way of doing it. So another thing is all these models, the mode prediction, your question is applicable to the mode prediction as well, right? For example, I can be using car to come to home from BUET 80% of the time, but sometimes my driver is sick or sometimes something happened to my car. So maybe I took rickshaw or Uber on that particular day. So that shift can happen in case of mode, in case of route as well. So that's why none of these models are deterministic. So there's a difference between these two. I couldn't get into the detail of it. I tried to hint on it a little bit on the slide when I talked about the probability of deriving something. But all these models are probabilistic. So we basically come up with a probability that a person will do this as opposed to a person will do that. Okay. So that's one way of looking at it. The second way of looking at it is obviously, yes, you as a person, if you are going to BUET and then going to give a private tuition, and if I predict that you are going to BUET and then you are going to a restaurant, then I'll be completely wrong. But we actually predict at an aggregate level. So at an aggregate level, if it's not necessary that you always match an individual's activities, but if you can match in aggregate, if you can replicate, when I talk about replication, if you can match that 20% of the Dhanmondi area people go to the schools at these areas and 80% go to schools in Uttar area, that's enough. You don't have to match at the individual level. As long as you're matching at the aggregate level, as long as your model is predicting the baseline scenario. So that's the baseline scenario. Whatever activity events you are predicting, you can be wrong at the individual level. But as long as you are correct at the aggregate level, you will be able to replicate the baseline scenario. What is the baseline scenario? The baseline scenario is Dhaka is congested at almost 80% of the time. If you are able to predict that, and if you are able to predict the conditions, then you are good. But to answer your question in a single sentence, all these models are probabilistic. So you are just giving a probability. So all the events that you have mentioned, you'll associate a probability to that. So yes, you can never predict deterministically. It's never possible.
Oh, okay, madam. I mean, I was thinking that modeling activity would be difficult because you need to consider every possibility.
Yeah, modeling activities is difficult, but the difficult task, people have been doing that for the last 50 years, okay? So the activity-based modeling has started in 1970s, and people have been doing that for the last 20, 30 years in the US, in the Canada, in Europe, in some of the places. This is the state of the art. Nobody relies on the 4-step model. So yes, it's definitely difficult, and predicting people's behavior is always difficult. It's not rocket science. And I tell this in my master's class that when you are testing the value of G, which is the acceleration, you have to come to 9.81. And if it's say 7, then you have made a grave mistake. But in case of people's behavior, when you're predicting people's behavior, actually, if you are say 60% correct, we become happy. If you're 50% correct, we become very happy. So yes, it's very difficult. There's no doubt about that.
Okay, thank you, madam.
Thank you.
Now I have a question.
Yeah, please go ahead.
Ma'am, in your discussion, you have talked about empty mile transportation or empty mile traffic.
Right.
My question is, how can we reduce it? Or my second question is, how can we accumulate it when a single car is used by multiple family members?
Okay.
In the case of Dhaka,
a very nice question. So, so empty mile is so you have to understand the notion of transportation first. We have to understand actually it's not you or me. Actually, when we are making policy, when we are actually making flyovers, we forget that we want to move people and not cars. So since we see these cars on the roads all the time, we think that if we can move cars fast, we will be happier. But that's not the point, because you want to move people. So the empty mile definition applies to Dhaka when a car is moving, when there is nobody in the car, only the driver is running the car. The driver is moving an empty car from one place to another. That's not serving anyone. So that's the empty mile. Okay. In my definition, that's an empty mile. So empty mile, in my understanding, nobody has used the term empty miles for Dhaka yet, but I do refer to it as empty mile when a chauffeur is you are running the car without anybody in the car, because a car or your objective should be to serve a person's purpose. A person has to go to somewhere, either to work or to school or to meet someone. So when a vehicle is just moving in between, it's not serving anybody's purpose. No person is moving. So that's why it's an empty mile. In Chicago, an empty mile is defined where an automated vehicle is moving from one place to another and it's not serving anybody's purpose. Nobody is in the vehicle. That's the definition of empty mile. I'll give you another, I'll try to define empty mile in another way. An empty mile is where Uber is moving from one place to another in search of a passenger without anybody in the vehicle. It's not serving anybody's passenger. It's adding to the congestion. Okay. When a CNG is moving from one place to another, when a rickshaw is moving from one place to another, it's not serving anybody's purpose. It's just a noise strip. We call it sometimes a noise strip. It's just creating congestion in your network without serving any people, because as a transportation planner, you are bound to serve people. You are not bound to serve any vehicle. If you can serve all the people without moving any vehicle on the road, if that's possible, you should go for that. You should minimize the movement of the vehicle. So that's why you should always be concerned when a vehicle is moving without anybody in the vehicle. So that's the anti-man. Okay. And then how to minimize, what was your second question? I probably forgot that.
My second question was that you have told in your discussion that in Dhaka city, when I consider about Dhaka city, when a car is used by multiple family members.
Oh,
so
yeah.
you said
Yeah.
that when I talk about,
I'll give you an example of
yes,
that.
ma'am.
So in my family, we are 3-member family, me, my husband, and my daughter. So 3 of us have something to do outside. My daughter go to preschool, I go to BUET, my husband go to his office. So we have a single car. So my car runs like crazy. It makes 5-6 empty trips because it drops me at office. We try to schedule our office in a way so that our time with her daughter is maximized. So we when if I go to I'm in the office in the morning, my daughter's father wants to be at home, and then my car does this BUET to Dhanmondi multiple times, and then in between it goes to the preschool to pick my daughter, again empty. When it comes back, it has my daughter, but when it goes to pick up my daughter, it's empty. So that's how it creates a lot of empty mile. And the same thing happened in my family when I was a daughter in my family as well. Me, my sister, and my brother grew up in a family with a single car, with both my parents working. And a single car used to serve multiple people's um, activity purpose. It doesn't happen in North America and Canada very often, because in their case, in most of the cases, the person who is driving the car is the one who is going for the activity. So the empty vehicle doesn't move from place to place, because usually the husband has a car, the wife has a car. When the child gets older, 18 years old, he gets a car or she gets a car as well. So the empty mile doesn't happen in that case. But in our case, when a single car is serving multiple people's purpose, it does a lot of empty mile. And sometimes I send my driver to, for something else, which has nothing to do with the car. He just takes the car to, bring some food or something else without any of us. Maybe that cannot be empty mile because it's actually serving a purpose. It's bringing me goods, it's delivering goods. But one trip is always empty. It's not doing anything. So in that way, when a single car is serving multiple people in the family, the car is supposed to make many empty miles compared to when each family member has a car to do the activities or participate in the activities. I don't know if I could answer your question.
Thank you.
Okay.
Yeah, yes, ma'am. Thank you.
Ma'am, Assalamualaikum. I have a question.
Please.
Ma'am, you have shown us some of your research works and they are so interesting. So I wanted to know what were the biggest challenges you faced when transitioning from traditional civil engineering methods to incorporating econometric modeling? And as a beginner, if I'm interested in this field, what approaches should I make?
Okay, thank you so much for your question. So basically what I understood is that if you want to delve into, so this was my journey. So some people actually become hardcore programmers, some people become very interested in optimization. So in my case, I became more interested in statistical modeling. So that's why I had to learn matrix algebra. I didn't have any matrix, a very good matrix algebra course in my undergrad years. So I had to learn that. I had to take actually many courses when I went for my PhD. I had to do courses from economics department to understand econometrics. I had to do programming course. So basically, if I had to summarize, I have to tell that if you want to shine in the field of transportation engineering, at least as far I know about the North America, in the US and in Canada, you have to be willing to learn math, matrix algebra, statistics, and then you have to be willing to do programming because, for example, the Google location history data, it's a very, very noisy data. Kaiser was the one who dealt with this data. He could only deal with this data because he was very interested in programming. He did everything in Python from the get-go. And he actually, interestingly, neither Atul nor Kaiser actually did their undergrad thesis with me. It was a project, actually. I was and we had a small project funded by CSR, and they worked as research assistant. But Kaiser was very interested in programming. That's why he could do it. I actually proposed this work to some of my other students, but they were not interested in it because the data manipulation part was very hectic. I had some code to start with. I gave him this, but Kaiser was very, very, excited to, he was always excited to work in the programming. So you have to be willing to do some kind of programming. I did, when I worked at Argonne, I had to code in C++. I will not call myself a hardcore programmer, but I was willing to learn. And I think these are the challenges. I think my hardest challenge was not probably programming. I would say the mathematical portion of it, because I was never taught to learn mathematics as a theory. So in order to do some of the innovations in the field, you have to have some kind of knowledge where you want to innovate in the field of statistics as well. So I think that was the hardest challenge for me, but it could be something else for somebody else. But you have
Thank
to
you.
read actually, and then programming and math. But if you are interested, you'll get there. When I started, I was also completely lost, but it's because of my interest I have come to this for it, at least. Yeah,
Yes, ma'am. Thank you.
thank you.
Assalamu alaikum, ma'am. I have a question too.
Okay.
Will you please reflect on the part data manipulation in research work? If we manipulate a data, what does it mean in research work?
I'm not sure what you mean by data manipulation. Are you talking about synthetic data generation or?
Ma'am, you mentioned earlier data manipulation in
Oh, okay.
programming.
Probably manipulation is not the correct word. So he had to, the data used to come in a JSON file. So manipulation meaning you have to just structure it in a way where you can use it for your modeling. So, for example, the random forest model, the data has to be in a format where you have one row for each trip, and then each of the column will contain the features that you want to include in your model. For example, the start time of the trip, the location of the trip, or the velocity of the trip, or the acceleration of the trip. So these are the features. You have to have the data in this format. But when we got the data from the Google location, we actually had different people's data. We had like 50 or 60 odd people's data. So they gave us data in a zip folder, and all these data were in a JSON format where you have this curly braces, and inside the curly braces you have the mode for one trip, the location for one trip. So it was in a very different format. If you know about dictionary, it was kind of in a dictionary of dictionary is kind of a JSON format. So from that format, you have to convert it into a format which looks more like an Excel table. So that's what I refer to as data manipulation. So basically data wrangling, probably manipulation is not the correct word. It's the data wrangling. You have to and actually that takes a lot of time in transportation, especially when you want to work with passive data, passively collected data, when you are not dealing with the data that is collected through a very structured questionnaire survey. When you collect data through a very structured questionnaire survey, I'm sure especially some of you who are from the 19 batch, your thesis is almost complete. So I'm sure many of you, either in your capstone project or in your thesis, you have collected data through a very structured questionnaire survey. So that data comes in a more structured format. But in the passively collected data, if you're getting data from the Facebook or from the smart card transaction or from the Instagram or from some social media data, so those data are not very structured format. So you have to be able to make that data or take that data in a format in which you can work with. So that's what I was trying to refer to. Yeah. Manipulation was not probably the right word.
Thank you very much, ma'am.
Thank you.
Ma'am, I have a question.
Yeah, please go ahead.
Ma'am, as we are engineering undergrad students, we don't have very strong background in statistics. So to be working in transportation engineering field at undergraduate level, like when we will do our thesis, so where to start in learning about statistics?
Yeah, actually, undergrad level, starting any research is very difficult. And actually, the first thing I'd say is you have to accept it. Research is a thing where you'll feel uncomfortable. It's not like even if you are the first boy or the first girl, when you are doing research, even now when I'm doing research, when I'm submitting a paper, most of my papers actually come up with, not most of, some of my papers get rejected. And when some of my papers come with a very critical review decision that I have to revise my paper. So it's a very uncomfortable thing to get because now I'm standing on this dais and I'm lecturing my students and I'm used to it. And then when I submit a paper, what I get is very critical review. So doing research is always it's a very uncomfortable zone to be in. So first of all, you have to accept it. That doing research, if you want to continue to do research in the long run, you have to accept that I'll feel uncomfortable. I'll feel like I don't know what I'm doing. But then if you are interested enough, you'll have to start somewhere. Your supervisor will hold your hand. And so it depends on actually what you want to deal with. For example, for my students, I basically do this very traditional statistical modeling or econometric modeling, which has been going on since, say, for last 100 years. Still, there are innovations in this field, but then there are some supervisors who are teaching their students or asking their students to do machine learning. So it depends on which field you want to delve in. For some of the students are becoming more interested in machine learning because more codes are available for machine learning. Whereas in econometric modeling, it's a little bit harder to get ready to use codes. So that's why sometimes that's a division line. So if you're more interested in machine learning, you'll find some codes in the GitHub, you can start there. Or you can ask your supervisor whether he or she is interested in, say, regression or risk adjust modeling, or more like in neural network. And there are very good resources now so for example, I myself has learned from many online lectures from Kenneth Trent is a person, actually I should mention. He is actually an economist. He was a professor at University of UC Berkeley, and he has these lecture notes available online, lecture codes available online. I actually sat down and read those codes in Gauss. Initially, when I started, I felt very uncomfortable, but then I realized that I have to learn it if I want to do something. So I figured this out. I learned from the codes of Chandra Bhatt. He is a professor at UT Austin. I downloaded his codes. He also shared his codes in his personal website. So I read his papers. So his papers are like books. So I read his papers and I learned from that. Then yes, that's how I learned, because but my supervisor did tell me that, okay, I want you to research in this particular field, because when you are starting as an undergrad researcher, it's very difficult to find out the field among all these many papers. So somebody will have to narrow that down for you, that okay, we have this and this and this to do, but given a limitation of 1 year and given the amount of fund that we can get, we can try A or B or C. And then when you figure out A or B or C, he will guide you which books can be useful for you, whether you want to go this route or that. And then there are some, I think there are some Coursera courses which might be helpful. I taught myself some neural network because everybody started to talk about neural network. I never applied it so far. I applied it a little bit for the last research that I've shown you. But I actually learned that course, the neural network, from a Coursera course. I paid for it. It was $30-40 probably. And then I learned from there. So yeah, that's how it happened, little in bits and pieces from here and there. And obviously my supervisors helped me to guide me to which line I should take. Yeah.
Thank you, ma'am.
Thank you. Yeah, I think Tasnim, you can tell us if we need to stop or if we want to continue.
Okay, ma'am. I think we don't have any question, so we can end it here. Thank you, ma'am, for giving us time from your busy schedule. And we are hope that if we arrange any seminar in future, you will be with us.
Thank you so much for the invitation. Actually, I understand that মানে এটা তোমাদের একটা সেমিস্টার লাস্টের দিক, সো তোমরা আমার থেকে বেশি বিজি থাকার কথা এই সময়। তারপরে the many of you have participated and খুবই সুন্দর সুন্দর কোশ্চেন করেছো, বোঝা গেছে কথা শুনেছো, ক্লাসের থেকে একটু বেশি কথা শুনেছে বোধহয়, ক্লাসে তো অনেকে ঘুমিয়ে পড়ে অনলাইনে। সো I feel very grateful for that, for arranging it. And আমি যদি রেকর্ডিংটা যদি আমার সাথে আমি জানি না তোমাদের আইটি এর মানে রুলটা কি, বাট যদি রেকর্ডিংটা শেয়ার করা সম্ভব হয় মানে আমার খুব খুশি হব যদি রেকর্ডিংটা আমার সাথে শেয়ার করা যায় কোনোভাবে।
জি ম্যাম, আমরা শেয়ার করে দেবো আপনার সাথে রেকর্ডিংটা।
ওকে, ঠিক আছে, থ্যাংক ইউ তাসনিম, থ্যাংক ইউ সবাইকে।
Thank you, ma'am. Thank you everyone for participating. We are ending our webinar here.
Recording stopped.
Thank you everyone. Assalamu alaikum.